I'm Jim Sykora. I've been doing IT stuff since like third grade. I'm a security consultant at Trimarc Security now. I do Active Directory stuff. And if you want to find me and interact with me, I'm at the Trimarc booth later, or I'm on Twitter.
And I am Jake Hildreth. I've been doing IT stuff since like third grade too. I lead the Active Directory security assessment team for Trimarc and joined in 2021 and co-host with Mr. Kotsky over there, Rando, on Happy Hour on Fridays and maintain Locksmith. And somehow, weirdly, I am most active on LinkedIn. So come find me there. I know, boo. I don't know why. So let's get into this real quick. So who is DNS? The domain name system. This is going to be real quick. I'm sure most of you know what this is, but it translates names into IP addresses that can be used by computers, right? So it was born in the early 80s because before that, there was just one big host file that was shared among all internet connected computers, which is bizarre. And you had to call somebody to get on the list. Bizarre. They decided that didn't work. So they built out DNS. Provides recursive name resolution. So if your local computer or your local DNS server cannot find or, convert the name into an IP address, it asks somebody else. It is essential to the modern internet. We all love it. And yes, it's always DNS. And Addie, AD, Active Directory, used in like 95% of networks in the world. It's a combination of Kerberos and LDAP. So before Windows 2000 came out and the release of Active Directory, there was like a mishmash of name resolution between NT directory services or host files still. And even if they're using TCP IP, a lot of networks back there are using IPX, SPX. So, but then Windows 2000 came out. Active Directory was released 23 years ago. It's wild. Active Directory relies on DNS, which relies on Active Directory. So if you compromise one, you've compromised the other, right? The reason this happens is because instead of like your common DNS servers that stores zone files, Active Directory stores all of its DNS information in Active Directory itself. So they are codependent. So for a little more details on that codependence, Jim.
All right. So traditional DNS servers might have their information in that zone file, like bind or whatever you're using with the start of authority, all the records for that zone. Active Directory integrated DNS can do those local zones also, but Active Directory integrated DNS also stores replicated zones in Active Directory, like forest replicated zone, domain replicated zone, and like anything in Active Directory, they're a securable object. Within each Active Directory integrated DNS zone that's stored in AD, those records are stored as DNS node objects in Active Directory. So each DNS node object has attributes defined by the schema that define the record. So like the DC, the DNS property, tombstone values, multi-value DNS record, and where the node, that's where the data for the node is stored. So as you can see here, we have a DNS node that has more than one value. So this is a multi-value attribute. In how are DNS record properties stored? It's bit arrays. That's really not human readable, but to a computer, that's perfectly normal language. Here we go. So we're doing whose slide is it anyway? Right here today. So yeah, we styled our talk on the classic something old, something new, something borrowed, and something blued. So the old is prior art. The new is new methods of abusing DNS. Borrowed is proven defenses against existing attacks. And blue is tooling to help you secure your DNS. And since it's the WWHF files, we gotta throw some X files references in here. So I'm going to start out with the few old things, the previous research. Name resolution and poisoning has been around since like at least 2012, probably before that, but that's the earliest record of it that I could find of like responder and stuff on the Googles. So DNS resolution, a lot of times it's going to be like local link layer, multi-record LMNR, NetBIOS name server, or like multicast DNS. Kevin Robertson is a really talented person. I think he's at like NetSPI now. He did a lot of Active Directory integrated DNS research back many years ago, and started off abusing DNS with dynamic DNS updates. So with that, that's when the computer creates its own DNS record in Active Directory interface, but he couldn't create a wildcard record, which was something that he really wanted to do. So digging into it a little bit further, since Active Directory integrated DNS is just objects in Active Directory, he found that he could use LDAP to create DNS nodes for any object that didn't already exist. And the reason for that is because authenticated users have create all child objects on the DNS zones. So with that, he developed PowerMad, which uses LDAP to abuse Active Directory integrated DNS and other things. So that can make DNS poisoning work across different broadcast zones, whereas with LLMNR, or multicast DNS, you're stuck with a same broadcast domain. And then with DNS poisoning, you could also create single name UNC paths that default to intranet zone in IE, which, yes, IE is still in Windows, even though Microsoft says it isn't.
Don't tell.
And if you're in the intranet zone, you can coerce that with web client. So all that works mostly because Addie and DNS are joined at the hip. Most importantly, because, like I said earlier, any authenticated user can create those DNS nodes if they don't already exist. That's required because by default, the computers need to be able to create their own DNS records and manage them. And domain computers is part of authenticated users.
Along with domain users.
Correct. So I covered that, the default is any authenticated user can create any DNS node that doesn't already exist. But when digging into the schema around Active Directory integrated DNS, we noticed that authenticated users can also create things called DNS zone scope containers, and that DNS zone scope containers, you can create DNS zone scopes. This is a feature that was added with Windows Server 2016. Is it, there we go.
Yeah.
All right. So I modified a PowerMad function and created DNS zone scope containers and DNS zone scopes beneath it. These DNS zone scopes and the containers that hold them are going to replicate. Yeah. So here's a DNS zone scope. And we're looking at it from DNS Manager on that side. And we're looking at it from ADSI on this side. So those zone scopes can be created anywhere that they're a child of any type of zone in DNS. And those DNS zone scopes are generally intended to interact with DNS query policies and DNS resolution policies, which were also introduced in Server 2016. After running the new AD&DNS zone scope, how many times can I say Active Directory integrated DNS in one talk? DNS Manager looks the same over on the left, but in ADSI edit, you can see that there's now a malicious zone scope. But at that point, the ability to, again, any authenticated user can create DNS node objects underneath that zone scope. And that could be abused in other ways, but I kind of ran it into a dead end there as far as what authenticated users could do. You could maybe do something like an internal C2 channel. There could be some other things. I know that there's been research on using like certificate paths and Active Directory users to do like an internal AD C2. But within this, you could create DNS text records and as many of them as you want. So another topic here from older research is Durgan Malema and Elad Shamir did a lot of stuff on DACO reviews around relaying Kerberos unconstrained delegation and abusing resource-based constrained delegation. And tying that together with Kevin's research and what he did in PowerMad, there's a lot of tricky things that people are doing with those now. A lot of people will do like new new computer account in PowerMad and use that and abuse that to abuse resource-based constrained delegation. There's other things that you can do with those DACL abuses, the way that Kerberos works, and the attributes on computer objects in AD, such as additional DNS host name, allowed to act on behalf of other identity, SPNs, and then just kind of looked into the ways that DNS and Kerberos interact and can be abused. So there's 4 ways to store DNS zones. They can be a forest zone, domain, legacy, and files. We're going to skip files. That's like the old not integrated way, like bind. The screenshot on the left shows that each DNS zone might look like in ADSI edit, and on the right, it shows what the DACL, or at least a portion of it, on that Microsoft DNS container is going to look like. So forest DNS zones are stored in a specific partition, and they came about in Windows 2003. In Windows 2000, they didn't exist. They're replicated to every DC in the entire Active Directory forest, which is the security boundary of Active Directory. They have the strictest DACL. They don't even grant permissions to DNS admins. By default, like the MS DCS subdomain that came about in Server 2003, that's going to be a forest DNS zone. And that's where every client finds the KDC, LDAP endpoints, domain controllers. And yes, even in my lab, DNS is broken. So DNS zones are also stored, domain DNS zones are also stored in a separate partition. They replicate to all of the DCs in the domain, and the DACL is still pretty strict, but here domain admins are added to it and with full control, and DNS admins have almost full control that inherits down. So this is probably the most common type of DNS zone, but I'm not actually sure about that.
Something to research.
Yeah.
Oh, no.
And then there is also the slides that disappear. There's Jake, what did you step on?
There was a kid.
Yeah. So there's the Microsoft DNS system object. So that's kind of like what I call the DNS head object for Active Directory integrated DNS. And any DNS zones that are stored as a Windows 2000 legacy partition will also be stored under that container, and they will inherit permissions from domain root. So that DNS head object, like I said, it gets its domain permissions, it gets its permissions inherited down from domain root, which those permissions can sometimes be really atrocious.
Generic all at domain root, anyone?
Yeah. So just kind of to recap there, forest DNS zones, forest-wide, strictest permissions. Domain DNS zones replicate domain-wide, have the next strictest permissions. Legacy DNS zones replicate domain-wide and have terrible permissions. There's also some interesting things about legacy domain DNS zones, because you can create a DNS zone called a global names zone, and that'll support single label names, like, again, what are used in intranet sites. It was kind of a bridge between WINS and DNS. And it's still there. Also, the root DNS servers, aka the root hints, those are all stored in the DNS head object that inherits permissions from domain root. So those DNS, like I said, those domain and forest DNS partitions were added in Windows Server 2003. In Windows Server 2003, they realized that a lot of the things that they had basically copied from NT into Windows 2000 was a terrible idea. And they did that because AD replication bandwidth was such a big issue at that time. And for some people, it still is, like domain controllers on ships and submarines and stuff like that. But it also means that there's possible to have multiple copies of the same DNS zone accidentally or even on purpose. So you could have contoso.com namespace in a forest DNS zone, a domain DNS zone, and a legacy DNS zone. And you don't do that on purpose, really, but there is a way to do that by trying to make changes to the DNS zone when you don't have the right permissions to do it. So there's an order of precedence, words. So the DNS zone that is closest to the DNS server that is serving up those records is the one that's going to win. I don't know how well that shows up there, but as it goes for preference, the local legacy partition is going to be the one that wins out. So even if you have like the forest domain partition of DNS with the strictest ACLs, an attacker with DNS admin rights could create their own copy of that zone and mess with it. Another piece of Active Directory integrated DNS history. This is something that just finally got patched in 2021. This has been around since
2017?
Yeah. So Shea Bear found that DNS admins could use DNS command to load a custom crafted DLL into a DNS server. And in the case of Active Directory, that DNS server is a domain controller. And that DLL would run with system permissions. Yay.
Note, this is bad.
Yes. So that has now been patched. That was a known escalation privilege that was out there from 2017 to 2021, and it just finally got patched, like during COVID. That's pretty wild. So, that direct path from DNS admins to system on a domain controller or, total domain compromise is patched now on every domain controller server on Windows Server 2012 and newer, assuming that patches get installed. But there's also some other things that DNS admins can do that makes them a little bit more powerful than expected, and they're not protected by admin SD holder. So on the left is the DACL for DNS admins group. It has explicit access control entries, including allowing account operators full control over it. So what that means is that anybody who's a member of account operators or possibly like your help desk people can compromise DNS admins. On the right is the DACL for admin SD holder, at least in one of my lab domains. It can look different. But that DACL is pretty strong, like, only enterprise admins, domain admins, system, and administrator have really any control permissions over that. And when an object is protected in Active Directory, like domain admins, administrator, those types of things, this DACL gets stamped on all the members of those protected objects by the admin SD holder process itself. It has nothing to do with SD prop.
Not SD prop.
Yeah, more on that some other day. I'll talk to you all day about why SD prop has nothing to do with admin SD holder. Anyway, so what this means is that there's a lot of paths in a lot of environments to go from a standard user to DNS admins. And there used to be, at least until 2021, a pretty solid path from DNS admins straight to domain compromise. But the way a lot of environments that I see, in almost every environment I see, that it's rare to find a path or an environment that doesn't have at least one path from a standard user to DNS admins. So yeah, quick reminder, DNS admins has an explicit access control on that Microsoft DNS head object in the domain DNS zones and the legacy zones. They don't have full control, but they do have modify permissions and modify owner. And if you're the owner on an object, that is better than full control.
And go to the Trimarc Content Hub to get more details. Jim wrote a white paper called Owner or Pwned, which details why ownership is basically fuller control. So
yeah,
hub.trimarcsecurity.com. Thank you, marketing manager.
So anyway, a DNS admin could grant permissions to an arbitrary attacker-controlled security principal and cause it to inherit that down to all the legacy zones and all the root hints. So if you can, like I said before, if you are or can become the owner of an object in Active Directory, which they're all secureable objects, that's even more powerful than full control or generic auth. And now for something completely different. I'll be talking about a couple of the newer things I happened upon while exploring Active Directory integrated DNS. I think that's 26 times I said it. So defenders sometimes will use DNS sinkholes to prevent access to malicious or unwanted domains. That's pretty common even in like some DNS security tools, to just like, if you're trying to go to a malicious domain, we're just not going to resolve that, or we're going to resolve it to a landing page that says, hey, please don't go there. So that's pretty common for blue teamers to do that. But what if an attacker could do that to sinkhole traffic that might get them caught? Something they call an evil sinkhole. So going back to what DNS admins can do, they can create new domain DNS zones, legacy zones, and they can create local zones. And remember, the zone that is the closest to the DNS server that you're on has order of preference. So the local zone is the highest and the most used: legacy zone, domain DNS zone, forest zone. So any DNS zones for an external domain but hosted internally mirrors the concept of split brain DNS, which maybe some of you know about, and I'm not going to explain it. Basically, the DNS server thinks it's authoritative for the external domain, and it won't recurse it. DNS admins can also create conditional forwarders within DNS, and conditional forwarder is basically a rule that allows you to create redirect DNS queries for specific namespaces to specifically defined DNS servers for lookup. So that would let you do things like send queries to an attacker-controlled DNS server, attacker-controlled device, or potentially nothing. That's fine. Yeah. So those are some of the ways an attacker could use that is basically sending all your traffic for things that are important in your environment, like blinding your EDR. And I would hope that you're running an EDR that does not 100% rely on DNS to operate, because that is bad. I only had access to a couple of them, and luckily they all have IP fail-safes in them. So that's good. But there's sometimes you could blind a SIM if it's working by DNS, which seems like a lot of them are. You could redirect management traffic to different, from like, Windows Admin Center to fake Windows Admin Center. You could, redirect the any of these type of traffics here, and it's fairly noisy and wide ranging. It's going to affect everybody that connects to that specific DNS server, or probably that DNS domain. What if there's a quieter way? So we talked about some things that were introduced in Server 2016. There was a bunch of new features for DNS with 2016, not just the zone scopes. So some of that stuff is things that are only manageable through PowerShell. There is no GUI for it. It will not show up in a GUI unless you are like in registry editor, ADSI edit. It is not surfaced in any of the standard management snap-ins. In a post-compromise scenario, remember, this is having administrative rights already. DNS policies could be created to filter DNS queries, redirect traffic, again, the split brain theory, perform targeted poisoning, could also be combined with DNS zone scopes and replicate and poison that traffic across multiple DNS servers. So these are not really widely known. I just stumbled on them like earlier this year. They've been around since 2016, but I've never seen anybody use one. I hope that they would, because they can be used for a really wide range of functions, from good and bad, but they're designed for good. So how many of you have ever created an SPN? How many of you ever deleted an SPN? Okay, so it's kind of like a little bit more experiment or theory here, and something I'm still working on. Like, I kind of feel like I know Kerberos, but every time I think I do, I know that I need to learn more. So just as Active Directory integrated DNS relies on Active Directory to function, many parts of Active Directory rely on DNS. They're co-dependent. Things like Kerberos. Yeah, just in case you were missing Tim over there, we threw him in a little bit. More specifically, Kerberos relies on user principal names and service principal names, and those in turn rely on DNS. Next. So there was a couple blog posts that I was looking at referencing there from, and I totally missed that.
They're included in the resources.
Yeah, they're in the resources. So there's blogs from again Dirk Lama, Kevin Robertson, Elad Shamir, and Charlie Clark that have to do with things like relaying Kerberos and attacking Kerberos. So most of those blogs were focused on either a way to add an SPN to an account that already exists or create an account with an SPN. But what if we could just compromise an account that's already in Active Directory and that it's configured with multiple SPNs, or an account that just has an unused SPN? Those SPNs are always added, but like we did in our little survey here, they're almost never cleaned up. So, what if we could use one of those, what I like to call dangling SPNs? Like, to be fair, Elad Shamir coined them ghost SPNs, and maybe that is more better for Deadwood with all the paranormal activity, but I like to be silly, so I call it dangling SPNs. So with unconstrained delegation, that might look like a user with unconstrained delegation configured. Usually when you have a computer with unconstrained delegation configured, you want to compromise the computer object itself. With users, you want the account and the SPNs. So with Kerberos magic, like constrained delegation with protocol transition, be like looking to route the allowed to delegate traffic to a higher value service and do some DNS poisoning and alternate DNS host names. So the caveat is that I'm a defender by heart, and I'm only just starting to like think about how I can break things, and I'm really not great at it yet, but I'm working on it. So hopefully I'll break this completely, or somebody will help me out, and we'll get these dangling SPNs all figured out. But it's probably not working because of DNS. So now that I brought something old, something new to Active Directory and DNS's 23rd birthday celebration, you might think about or already have outsourced your Active Directory DNS functions to a third-party service, maybe like Bind or one of those cloud-hosted DDI solutions. But it's critical to AD as DNS is, are you sure you want to delegate that tier 0 control plane service away from your tier 0 domain controllers and give full control of DNS and by proxy Active Directory to your networking team or a third-party SaaS provider? Instead, let's have Jake tell us about something borrowed.
Thank you so much, Jim. So as we talked about earlier, we are borrowing all of these defenses. These are all very well-known things that can defend against everything that Jim just talked about, right? So y'all know Black Hills. Black Hills swears by disabling LLMNR, NBNM, NS, and MDNS. They are not needed in a modern environment. Please just get them disabled. Another thing that you can use to defend against, as Jim talked about with PowerMad, the wildcard record, right? A wildcard record allows any misspelled or whatever, anything that does not immediately resolve, the wildcard record fills in. If you don't already have one of these in your environment, create one today. So that way it cannot be created by somebody using PowerMad.
Yeah.
Same thing with the WPAD record. WPAD record, web proxy auto discovery, allows web clients to figure out where the proxy is in their environment.
It's another nice IE throwback that's still enabled by default on every client. Still
enabled by default and still abused all the time. For both of those, create them today. That being said, please just use fully qualified domain names for everything. And then the DNS admins group, despite everybody thinking now it's been neutered, we've shown DNS admin still has incredible power across your DNS. So please empty that thing out. And if you must keep DNS admins in for whatever reason, don't. But if you absolutely must, make sure that those are members that are also protected by the admin SD holder process. So that way, at least they cannot have DACL abuse applied to them. Legacy zones, as Jim talked about, it's stored in the DNS head object. It's there for Windows 2000 compatibility reasons. If you're still running Windows 2000 and it's not OT or ICS.
Anybody running Windows 2000 still? All right.
Yeah. Okay, so you keep your legacy zones. That's fine. Everybody else, convert them, and make sure you have the permissions properly to convert them, or else you're going to create the duplicate zones that Jim talked about. Last thing on the list here is the global query block list. What the global query block list does is basically a list of names stored on each domain, on each DNS server that says these are names I will not resolve. By default, this should include that WPAD record and ISATAP. You can add other ones in there that are no malicious, names, but those at a bare minimum need to be involved.
DNS admins can edit the global query block list. But
that's good to know. One thing we did, or that Jim touched on, was in DHCP. When a computer requests a address, it then updates DNS dynamically, and they own that record. Windows DHCP servers can actually allow you to set up a service account that performs that dynamic update on the computer's behalf. So having that in place means then that it is a lot easier to go ahead and audit the ACLs on everything. If you see a DNS node that it was created by someone other than your dynamic update service account, you know that is probably an indicator of fuckery.
Yep. And it also removes the ability of the domain computer to modify its own and do its own DNS updates.
Right. Speaking of DACLs, so as Jim showed, there are about 1.5 billion different ways to abuse DACLs on all the various DNS zones. So yeah, just make sure that those are audited and cleaned up and, removing any crap that doesn't make sense. Same thing with DNS zones. Do they actually make sense for your environment? Do you need a zone for hackers.russia? Probably not. So just check that out. Same thing with zone scopes. Policies, that's where we get into those query resolution policies and query the other thing policy that I don't remember what it is. Because you are probably not using them anyway, if they exist, that's probably bad. And if you know what they are, you should be able to tell whether they are the ones that you created or not. And I didn't step on anything this time.
Did I do it?
I don't know.
Yeah,
maybe. And then, of course, audit the dangling SPNs. You don't need anything dangling. So I know that sounds like a lot of stuff to look at. And it is. It really is. However, we have something for you. And also, we're not just wearing these dumb t-shirts for no reason. Blue Tuxedo is a tool. Holy shit, Danny. I have stickers later. Yeah, stickers back in the Trimarc booth. We got a lot. So, on you? Like stuck to you? Oh, baby. What Blue Tuxedo is, it is a tool, pure PowerShell, using about three additional modules, DNS server, DHCP server, and Active Directory module. Oh yeah, I wrote it. You don't know anything. All right. It runs through your environment, all domains in your forest, to find those dangling SPNs, to report on your DNS admin membership so you can, lock it down. Tells you if your wildcard record is the correct type or even exists. Same thing with WPAD record. Check in that global query block list to make sure those records that are supposed to be there are actually there.
Yeah. Jake, do we have a demo of this?
Buddy, you are in luck.
Right. Let's go to that since we got a late start.
Yeah, let's do that. All right. So here is the demo, and I don't know how I'm allowed to skip ahead on this thing. Oh, hey, I can do this. All right. So this is just, like I said, pure PowerShell. It is a module. It's not on PS Gallery yet because I left my API key at home. Shh, don't tell. So yeah, right now we are just running through The Jim's lab that I hate the domain names of, because why?
I made him type that out so many times.
Every time. So we go through that, and then we test all of the collected information just to make sure, see whether it fits our requirements or not, right? Do we have tombstone records? Are the zone scope containers empty, etc.? So do we want to see it? Let's see it. So this is all of our ADI zones, Active Directory integrated zones, in the blue tuxedo.dangling.spns.lol.IHateGym forest. There are quite a lot. I made this lab. I might have overdone it a little bit. But we needed to test all the different variations on all the different servers. So here are the conditional forwarders. Again, do these conditional forwarders make sense in your environment? I can't tell you that, unfortunately. Dangling SPNs, clear lists. These are ones where the host portion of the SPN has been, does not resolve. DNS admins membership. We've got a list of all the members of DNS admins. Do they make sense? Probably. Probably not, actually. Here we see, I'm going to pause real quick here because I like this one. Telling you on each DNS server what the name of the service account is that's running it and whether one even exists. Forwarder configuration. We've got every single forwarder that's configured on each DNS server. Global query lock list. Do you see any WPAD? Do you see any ISATAP? No. Here are those non-ADI zones. These are the ones that are stored on each DNS server. These, in general, in an AD environment, bad.
Sometimes they're necessary.
Sometimes necessary, but in general, why? And then global query block list. We've got, query resolution policies. These are the ones that cannot be found in a snap-in, etc. These are per DNS server. They must be pulled out via PowerShell. And then one thing that we didn't touch on really was socket pool size configuration. When your DNS server makes a query to another DNS server, it randomizes the source port in order to just minimize adversary in the middle attacks, right? By default, that's 2,500 ports, but you can go up to a maximum of 10,000. So why would you do anything less than the maximum?
Can we turn it up to 11,000?
Oh, no, 10,000, unfortunately. And then tombstone DNS nodes. These are something that we didn't really touch on, but basically you can mark a DNS node as being tombstoned and then zero it out. An attacker would do this. So that way, when the next scavenging goes on, the tombstone record gets released. And now the attacker can now create their own DNS zone or DNS node to replace that tombstone record.
Yeah. And authenticated users can create any DNS node, but they can't delete the ones that they create. So that's the way to go about it.
Yep. You're like, I need to clear this out. What do I do? Tombstone. All right. And then, wildcard configuration. Again, just telling you whether one exists and what type it is, because that's important in various environments. And same thing with wildcard records. So zone scopes, they need to contain zone. Yes. This is blowing by me now at this point. Let it go. Well, I'm going to let it flow over me. So now, do we want to see what those DNS issues were with that collected data? Sure. So these are all your conditional forwarders. Again, because there's not a real way for me to tell you what is a good conditional forwarder in your environment, we're just going to list them. Take a look at them. Dangling SPNs. These are bad. You should get rid of these. Done. And as you can see across the top, we are now starting to include a description of why it's bad. So that way you're not kind of stumbling through things. DNS admins, let's get rid of those people. Non-ADI zones, as we talked about earlier.
Sorry for your networking staff.
Query resolution policies. Again, this is just an audit one. I can't tell you. Tombstone nodes, again, just repeating the same information. Zone scopes. This is where we start getting into weird stuff and zone scope with legacy ADI zones. These ones, that's what Jim was talking about, what we talked about, Windows 2000 compatibility in legacies. zones. These are the ones that you should change into forest or domain replicated zones. And as you can see, this lab is dumb and has way too many legacy zones.
Yeah. We break DNS a lot by trying to do stuff with DNS.
So here we go.
Just like y'all.
Back to the dynamic update service account, right? So as you can see, there is no service account configured here. So we're gonna tell you that. And then what's next? I don't know. Yeah. We'll see.
So basically going through all the checks that Jake talked about on the previous slide, and there's a couple getting into here where
this one
gives information on how to resolve the issues.
Yeah, so as you can see here, we are now at actually giving you code blocks on how to resolve the issues that have been identified. Yes, Brandon. And I know that seemed like a lot, and so you can actually do this on individual checks as well. So here, I chose socket pool size for this one because it's easy to remediate, and it makes a lot of sense for the demo. But so we see here, we get the socket pool size. We see 2,500 on both of our DNS servers. We go ahead and test that, right? Apologies for my slow typing. This was last night. And as we see, 2,500 is less than the maximum of 2,000. We are going to go ahead and report that to you. Now we go ahead and get the repair. And again, we get a full code block on how to repair that. Now, Jake, you say, I am lazy. Hey, me too. Cool. Let's do this the easy way, right? Let's go ahead and just run those code blocks. So we're going to go ahead and run. Done. We're going to go ahead and redo the get and make sure that has really changed. Cool, it has. We now have 10,000, right? And let's go ahead and test that and see if we pass or fail the finding check. 0 results, 0 problems. Fantastic. Well, 0 problems in this one specific issue. Let's not go any further. So yeah, that is Blue Tuxedo. It is available today. I published it on GitHub last night, github.com/TrimarcJake/Blue Tuxedo, or the Trimarc GitHub repos at github.com/Trimarc. We still want to add more remediations. We have 4 of the 14 or so checks written. Shockingly, some of these are difficult to write. Yeah, but I actually hid all of the access control stuff because there are so many items in DNS zones or DNS partitions. It's just a mess. We need to filter those better. Better descriptions. You can always be more descriptive. And of course, a text-based user interface, because I don't want to remember all those commandlets, and I don't think anybody else wants to remember all of those. So that being said, we are always looking for contributors. So please, if this is something you are interested in, either the attacking side or the defending side, please, just go join us on the GitHub repo. And if you don't even know where to start, come talk to Jim and I at the Trimarc booth. We're over by the buffet line, the best place. And yeah, we will help you out. We want people to, we want to give back to y'all. And we want y'all to help us too, because it's
and the other thing about this too is Blue Tuxedo, we came from relatively small environments where we didn't have resources, knowledge, people to bounce things off of, budgets, tools, any of those things. So this is this for Fortune 500 and large enterprise? Not really. I mean, you can try and run it in there. It might work. Should you just remediate your Fortune 500, DNS zones with our tool? No, this is for the small, sysadmins out there and the people that are doing things at a little bit smaller scale, but also to bring awareness to the issues for larger environments as well. Kind of like what we've done, what Jake did with Locksmith.
Yeah, similar to Locksmith, find and fix. So that's what we want to do. So that's pretty much it, man. I think Active Directory and DNS are now, they've resolved all their issues. They've gone through therapy. Everything is good now. I don't know, maybe not. Yeah, so that's about it. I just want to say thank you real quick to Kevin Robertson, Shea Bear, Charlie Clark, Dirkian Molema, Elad Shamir. Jim stole all their work and just made it cooler. And then we want to thank Wild West Hackin Fest for having us out, Trimarc for supporting us in our journey through this. About a year ago, Sean was like, hey, DNS. And I was like, hey, give me a year. Here we go. Coming to an Active Directory security assessment near you very soon. And lastly, thanks to all y'all for actually coming out here and getting in here. And
really appreciate it.
Yeah, love that y'all came out. So yeah, if you got any questions, hit us up. We are running late. Hit us up at the Trimarc booth, and we will chat. If you want to get in contact with us, please scan the QR codes. I only promise a little malware. No, I don't know how to do malware. I'm a defender. Come on. But yeah, here are the resources. All of these slides will be up and available on Trimarc Hub, hub.trimarcsecurity.com shortly.
We had one question.
Yeah.
From Tyler. What permissions does Blue Tuxedo need?
So in order to look at the information and just review and pull the information down, authenticated users in most environments. There could be some other environmental issues around that, but for the most part, just being an authenticated user, so a domain user, to pull the permissions down. In order to actually make any changes, you need to have administrative permissions for that. And depending on what you're actually changing, it could be a DNS admin, which you shouldn't use, or a domain admin, or maybe even a enterprise admin.
Thank you.
Yeah, thank you.